It was supposed to be just another interstellar rock, a visitor from beyond our solar system, cold, ancient, dead. But last night, something inside 3I/Atlas started moving, and no one can explain why. I'm a research astrophysicist. I've spent 15 years studying comets, asteroids, objects that shouldn't surprise us anymore. But this morning, when I opened the latest data from Gemini North, my hands were shaking. Because what we're seeing, it doesn't behave like ice sublimating. It doesn't look like a comet fragmenting. It looks like something waking up. Let me take you back. January 2025. The Atlas survey in Hawaii picks up a faint smudge moving through Ursa Major. Designation, C/2025A1. Orbital analysis comes back days later, and that's when everything changed. This object didn't come from our solar system. Its velocity, its trajectory, both pointed to extrasolar origin. 3I/Atlas became only the third confirmed interstellar object we've ever detected, after Oumuamua in 2017, after Borisov in 2019. But 3I/Atlas was different from the start. Spectroscopic data showed an unusual composition, extremely high carbon dioxide ratio, almost no water ice. It started out gassing early, far earlier than any normal comet should, while still beyond Jupiter's orbit. Some researchers called it anomalous. Others said it was just exotic chemistry from another star system. We cataloged it. We tracked it. We assumed we understood it. We were wrong. October 12, 2025. James Webb Space Telescope captures a routine infrared pass of 3I/Atlas. Nothing unusual. Faint thermal signature. Outgassing plume consistent with sublimation. Then October 13th, same target, same wavelength. The signature changed. Not gradually, not smoothly, it shifted. A region near the nucleus, approximately 200 meters across, showed elevated thermal output. 12 hours later, it glowed again, same location, same intensity. Then it stopped. 3 days pass. We think it's over. And then it happens again, but this time, in a different region. Faintly, rhythmically, as if responding to something. Comets don't do this. When ice sublimates, it's chaotic, driven by solar heating, surface cracks, random jets. But this was localized, repeating, almost geometric. Dr. Anya Volkov at ESA ran thermal models for 48 hours straight. Her conclusion, and I quote, "No passive sublimation model fits this behavior." So we expanded observations. Gemini North, Keck Observatory, even pulled archival data from Mars Reconnaissance Orbiter's wide-field surveys. And we found something else. The nucleus is changing shape. Not fragmenting, not crumbling, reconfiguring. Sections that were convex 3 weeks ago now show concave depressions. Internal voids are appearing where solid mass used to be. It's as if the object is reorganizing itself from the inside out. One of my colleagues, a man who's been in this field for 30 years, looked at me yesterday and said, "What could possibly move inside a comet?" I didn't have an answer. I still don't. So we started asking the hard questions. The safe explanation? Internal collapse. Pockets of volatile ices, carbon monoxide, nitrogen, trapped under pressure for billions of years. Solar heating triggers release, cavities form, the structure shifts. It's plausible, it's natural. But it doesn't explain the timing, the repetition, the localization. Then there's crystalline reconfiguration. Interstellar space is harsh. Cosmic rays bombard objects for eons. Some materials, silicates, clathrates, can store energy in metastable states. Maybe 3I/Atlas is releasing stored energy as it warms, triggered phase transitions. It's exotic, but it's physics. Except, the energy output we're measuring is too high, too organized. Which brings us to the theory no one wants to say out loud. What if this isn't natural? What if 3I/Atlas isn't just a comet, but something designed? I know how that sounds, believe me. But let me give you context. In 1981, physicist Frank Tipler proposed the concept of self-replicating probes, von Neumann machines, autonomous explorers that could traverse the galaxy, replicating themselves using raw materials. If an advanced civilization wanted to explore the cosmos, they wouldn't send crude ships. They'd send machines, small, durable, patient. And they'd make them look unremarkable, like rocks, like comets. Because who would look twice at a comet? Dr. Tariq Abbasi, exoplanet researcher at Caltech, said something chilling in a private email last week. He said, "If I wanted to study a solar system without being noticed, I'd make my probe look like debris." Now, I'm not saying 3i/Atlas is a probe. I'm saying the data doesn't behave like anything we've seen before. And when NASA convened an emergency panel last Thursday to discuss observation priorities, half the room argued for caution. Don't speculate. Wait for more data. The other half? They were quiet, too quiet. Because they're seeing what I'm seeing. Patterns, geometry, timing, things that shouldn't exist in a dormant chunk of ice. November 8, 2025. 3i/Atlas crosses inside Mars orbit. Solar radiation intensifies, surface temperature rises. And the signals escalate. Infrared observations now show heat patterns forming quasi-symmetrical distributions across the nucleus. Not random jets, not chaotic outgassing shapes. Thermal emissions concentrated along what looks like internal channels, like veins lighting up beneath cosmic ice. And the pulses? They're getting faster. Every 8 hours, then every 6, not every 4. Dr. Kenji Tanaka at Subaru Telescope measured rotational data. 3i/Atlas is changing its spin axis, gradually, deliberately, as if aligning itself with something. Some researchers think it's just torque from asymmetric outgassing. But others, they're not so sure. Because 2 days ago, radio telescopes in Australia picked up faint electromagnetic noise near 3i/Atlas. Broadband, low intensity, could be natural, could be. But the frequency distribution has structure. Not language, not a message, but not random either. It's as if the object knows it's being watched, and is responding. One astronomer, who asked to remain anonymous, told me. It's like it woke up when it got close to the sun, or maybe, when it detected us. That thought keeps me awake at night. Because if that's true, if 3i/Atlas activated because it sensed our electromagnetic signatures, our satellites, our radar, our transmissions, then it's not just passing through. It's here for a reason. I keep thinking about the Voyager probes, humanity's first true interstellar messengers. Launched in 1977, carrying golden records, symbols, music, greetings in 55 languages. We sent them out into the void hoping someone, someday, might find them, hoping they'd understand we existed. What if 3i/Atlas is someone else's Voyager? An artifact from a civilization that died a million years ago. Sent out into the galaxy, dormant, waiting until it found a star with planets, with warmth, with signs of technology. And then it woke up. Not to invade, not to communicate, just to record. To fulfill a mission programmed eons ago by minds we'll never meet. Or maybe it's worse. Maybe 3i/Atlas isn't a messenger. Maybe it's a warning, a reminder that intelligence doesn't guarantee survival. That civilizations rise, build, explore, and then vanish, leaving only their machines behind, wandering, functioning, outliving their creators by eternities. Because creation, once set in motion, doesn't stop just because its maker is gone. I don't know what 3i/Atlas is. No one does. But I know this, it's changing, it's active, and it's heading deeper into our solar system. In 3 weeks, it'll reach perihelion, closest approach to the sun. And if the pattern holds, whatever's inside is going to respond. Maybe we'll finally understand what we're looking at. Maybe we'll just have more questions. Or maybe, just maybe, we'll realize we were never alone. We were just too early, too loud. And something out there was listening. Stay close. This story isn't over. Maybe 3i/Atlas isn't here to meet us. Maybe it's here to remind us what happens when creation outlives its creator.